Okay, guys, lesson 6.4 is rational exponents. Our main job here is to look at and learn how to deal with radicals, so like square roots, cube roots, all that, and rational exponents, like how to go back and forth. When I talk exponents, you guys know I'm talking about the little numbers up top, right? What do I mean if I say rational exponents? What does it mean to be rational? If a number is rational, it's a number that can be expressed as a fraction. Okay? If it's rational, it can be expressed as a fraction. And so we're working with fraction exponents. Now, if you look up here at the top, okay, there's some information about how we go back and forth here. And so you'll notice the first one, it says x to the power of 1 over n is equivalent to the nth root of x. The key to note here is that the n in the denominator of the exponent, is the same as the n that indicates the root. So if my denominator is a 2, this is a square root. If my denominator is a 3, this is a cube root. If my denominator is 4, this is a fourth root. Okay? The other piece over here, similar, x to the m over n power. And that indicates, notice the n is still in the same location, right? That denominator is your root or your index. The nth root of x to the m. So that means your number on top, your numerator, is your power. And it can be written one of two ways. It can be written as the nth root of x to the m, or the nth root of x raised to the m power. And I'll talk about that a little bit later, and definitely more tomorrow, about what that means. But the key here is we go back and forth. The number in the denominator is your index number. Okay, it tells you what type of root it is. Now, an example of something that you might see today to kind of get you guys headed in the right direction. If I say the cube root of x to the 6th, what would that mean? The cube root of x to the 6th. X to the what? And where did you get that from? Yeah, that's the direction I was going. I could see it that way too, I guess. But okay, so the idea of this is the cube root of x to the 6th. Where's the 3 go? The 3 is the index, so it is the denominator. The 6 is the power. Where's the power go? On top. So this is the same as saying x to the 6 over 3. But what do we know about 6 over 3? It's 2. That's some of what we're going to be doing today. Going back and forth, learning location. Stay with me, focus with me. And the key is, just knowing which number goes where. It's just two numbers. You've got a 50-50 shot here. And if I didn't say it, have your blue papers near, because we are going to talk about the blue paper. We are going to use the blue papers on occasion still. Let's look at example 1a. The problem is 216 to the 1/3. And it says to simplify plenty of them. Okay, so 216 to the 1/3. We're going to simplify this. Let's start with, what does it mean? 216 to the 1/3. That is the what of 216? Cube root. The cube root, because the 3 is in the denominator, so what's that say? The 3 is your index. The cube root of, officially you could say 216, that 1 on top could say 216 to the 1st. So the cube root of 216 to the 1st. Which, do we know the cube root of 216? Yeah, it's on our blue paper, isn't it? Don't even have to grab the calculator. It's on the blue paper, and remember you can just count down 2, 3, 4, 5, 6. So cube root of 216 is 6. Okay, questions on what I did there? Okay, let's try B. 7 to the 1/2 times 7 to the 1/2. So my 7 is going to go under the radical. What does this 1/2 say? The 2 is my index, so this is the square root of 7 to the first if you want, or in other words, the square root of 7. And the other 7 to the 1/2 is square root of 7. What's the square root of 7 times square root of 7? Okay. You can think square root of 49, because remember, as long as they're the same root, you can multiply. Square root of 7 times square root of 7 is square root of 49, but we know the square root of 49 is 7. You could also just think square root of 7 times square root of 7 is 7 if you want. Okay, you guys are going to have to talk to me and give me some of these numbers so I know what we're doing today. Or that I know that. So C, 5 to the 1/4 times 125 to the 1/4. So again, rewrite them first as radicals. 5 to the 1/4. 5 goes under the radical. What's a 1/4 power mean? Okay. The 4 is your index, it's your root, so the 4th root of 5 to the first. And then we're also doing the what? 4th root of 125, because 4 is my denominator, so that makes it the 4th root of my base 125. Can I multiply those? Yeah. In order to multiply them, they just have to be the same roots. These are both 4th roots. So the 4th root of 5 times the 4th root of 125 is 4th root of 625. Oh, is it a perfect 4th root? You can check the blue paper out if you want. The 4th root of 625, whoops. It's right here, yes? Always start with 2, 2, 3, 4, 5, and you can write them on your paper if you need to. So 4th root of 625 is 5. Questions so far? Okay, moving along then. D, 64 to the 1/2 power. Okay, what goes under my radical? And that, of course, is 64. What type of root is this? Denominator of 2 is my index, making this a square root. And hopefully you can do this one without the blue paper or calculator. What is the square root of 64? 8. E, 11 to the 1/2 times 11 to the 1/2. Okay. Put them under their radicals. Denominator of 2 is my index. Same thing on the other one. 11 under the radical. Denominator of 2 is my index. Square root of 11 times square root of 11. Okay. I think I heard, did I hear out there square root of 11 times square root of 11 is 11? But it is also square root of 121. Just know, don't stop at square root of 121, but check and see that it is a perfect square. And remember, the shortcut I'm using there is that when you multiply two identical square roots, you get whatever's under the square root, right? Okay, F. 3 to the 1/2 times 12 to the 1/2. Okay, what does 1/2 say? Have you gotten this figured out yet? Denominator is 2, making it a square root. So square root of 3 times square root of 12. What is square root of 3 times square root of 12? Square root of 36. But we know the square root of 36 is 6. Okay. That was breaking you in there. All of my numerators were 1, so it's just a matter of figuring out, okay, my denominator indicates my root. Now let's go down to example 2. In row 2, or example 2, we are going to be looking at going back and forth. So in the first row, we're going to be going from exponent form to radical form. And then we're going to flip-flop it on the bottom row, and we're going to go from radical form to exponent form. So again, it's using that rule to be able to convert back and forth. So if I look at A, which of the following expressions is in radical, or what are the following expressions in radical form? So x to the 3/7. Okay, we want it in radical form. There's my help. Okay, so 7 is my denominator here, so 7 goes, here's the index, and then this is, the power is 3. So when I read that as the 7th root of x to the 3rd. Okay? Now, I am fine with writing it like this. I will ask, are there any perfect 7th roots in there that we can pull out? And no, to have a 7th root, there has to be 7 of something. Do I have 7 of something? No. So, to me, this is what naturally comes to mind in writing it, which is obviously why I wrote it first. However, if you look back up at the definition, there's another option with parentheses. And instead, you could write it as the 7th root of x, and then parentheses, raised to the 3rd. Okay, you can write it either way. Math Excel, I would think, would take it either way. And they mean the same thing. When we go and we actually have a number in there, the difference is that I can either do the number and raise it to the power, and then do the root, or I can do the root of it and then raise it to the power. And it usually depends on how easy my numbers are to work with as to which I do first. But both are acceptable. Okay? Okay, B. Y to the negative 3.5. Right now we have it in exponent form. We're trying to go to radical form. What's different about this problem, though? It's a decimal. We need it to be a fraction. Well, what do you guys know about 3.5? What's another way to say 3.5? 3.5? That's exactly what my brain would go for. So if this is y to the negative 3.5, okay, let's rewrite it for the moment as y to the negative 3.5. Now, do we have a rule for a mixed number, though, like 3.5? No, it has to be a fraction. So how do I make 3.5 an improper fraction? Do you remember? 6 plus 1 makes it 7. So this is y to the negative 7/2. Going back to some, middle school rules there? I don't know if you learned that in middle school or elementary, but so 2 times 3 is 6, plus 1, 7/2, the negative just carried over. Okay, now something more recent. We don't have a rule of how to deal with a negative exponent either. Or not, it's not part of our issue here. So we need to get rid of that negative exponent. We talked as recently as December about how to deal with negative exponents. Do you remember how to deal with negative exponents? Here's some stuff being said, but I can't make it out. No. Well, not exactly. You might be thinking along the right line, so I'm not sure. How do we get rid of a negative exponent? Remember the fraction bar? To get rid of a negative fraction or a negative exponent, you move it to the denominator. So if this is y to the negative 7/2, to make it y to the positive 7/2, we're going to move it down below. So y to the negative 7/2 becomes 1 over y to the positive 7/2. I promise you've done that. Okay, remember negative exponents, to get rid of them, move them to the denominator. Once you get rid of that negative exponent, we can use our rules now. We can use our rules of how to change exponents to radicals. So 1 over y to the 7/2 is going to be 1 over some type of radical. What radical goes there? What was it? No. What's my denominator? 2. Where's that 2 go? Index. So the 2 goes in the index. The 7 goes on as the power. So it's 1 over the square root of y to the 7th. Now, a couple of cleanup thoughts. One is you can pretty much just leave it as is and say 1 over the square root of y to the 7th. Noting, you don't need to write the 2 in for the square root. I'm doing it today so that you guys physically see where that 2 goes. And you're not just saying, oh, I don't understand this. The numbers are just disappearing. No, they're still there. You can see the 2, you can see the 7. Now, good news, in my notes I did not rationalize, which means that homework shouldn't be expecting you to rationalize, which means you're going to be allowed to leave a radical in the denominator. Now, I do have another answer here, and I can't remember which way MathXL leaves it. But, let me ask you a question. Square root of 7, square root of y to the 7. Are there any perfect squares, or let me start with, is y to the 7th a perfect square? No, because why is it not a perfect square? In order to do a square root of a power, you have to take that power of 7, be able to divide by 2. So 7 does not divide by 2. But if 7 doesn't divide by 2 as a power, what do I ask myself? Yeah, closest number below 7 that does divide by 2. There's something closer. Yeah, closest number below 7 that does divide by 2 is 6. And so I can simplify this a little bit. So my denominator is square root of y to the 7th. We have a perfect square of 6. And then if we say y to the 6th, the leftover piece is y to the 1st. So 1 over, what's the square root of y to the 6th? Yeah, 6 divided by 2 is going to make it y to the 3rd. And then square root of y to the 1st just stays square root of y. As I said, I have both answers in my notes. In all honesty, I feel like you can probably leave it as the 1st, but I don't really remember off the top of my head. Okay? Okay, C. Before you start C, can you read that problem? It's W to the negative 5/8. That's not just a really long fraction bar, it's a negative sign. You'll discover the computer struggles with getting these small exponents and everything. So, okay. W to the denominator. So W to the negative 5/8 becomes 1 over W to the positive 5/8. Okay, they want radical form. Are we there yet? There we go, guys. 1 over some square root. Okay. W is my base. It goes under. Denominator is 8. So this is the 8th root of W to the 5. Are there any perfect 8th roots in there? No, there's only 5 W's. So there can't be any 8th roots. So we're going to leave it as 1 over the 8th root of W to the 5th. D. Z to the 0.2. What's a little different there? Okay. Decimal instead of fraction. We don't have a rule to work with decimals, which means we need to get this to be a fraction. Okay, guys, think about it. I said it. I didn't use proper math language to say z to the 0.2. What is that? What? Yeah, z to the 2 over 10. If you read this properly, remember that first place is the 10th place. So this is z to the 2/10. But what do you know about 2/10? It reduces to be z to the 1/5. That made the problem a little easier. What root of z is that? Denominator of 5, so it is the 5th root of z. Okay, guys, I would like to think you are really getting the hang of which number goes where. It just takes a little effort in working to remember which one is which. And I know every single problem I feel like I'm saying denominator, index, root, index, something, or denominator. I keep reminding you what goes in the denominator every time. So, okay, bottom row. We're going to go the opposite way. So, what are the following expressions in exponent form? Square root of a to the 5th. Exponential form means I want a to some power. What do you know about the square root of a to the 5th? Yeah, my invisible index there is 2. And that means if you're kind of following, you've got a 50-50 shot. It's either a to the 2 over 5 or a to the 5 over 2. Where's the index go? On the bottom in the denominator. So that makes my 5 my power. So a to the 5 halves. And you get to leave it like that. B. 5th root of b raised to the 3rd. B to the 3/5, he suggests. 5 is my index, so it is my denominator. So b to the 3/5. C. 4th root of x to the 3rd. X to the 3/4, because then again, my 4 is my index, it is my denominator. And last one for this row, D. 6th root of y raised to the 4th. Okay, so my only comment is going to be, if you're going to tell me y to the 2/3, where'd you get it? Because I don't see a 2 or a 3 in this problem. Okay, so yeah, we're going to start by saying index of 6, so denominator of 6, so 4/6. But you guys have been well trained over the years. You know that 4/6 does reduce to 2/3. And so we're going to say y to the 2/3. On a basic fraction like that, yes, I would, majority of the time, if not all the time, encourage you to reduce it. So y to the 2/3. When I come back on Monday, are you going to be able to remember which number goes where? That's important. I mean, you know, it's just a, you know, focusing a little effort to memorize it. Okay. That is where I got at the end of 3rd hour and where I stopped at 6th hour. And considering I'm just recording one video tonight for all 3 classes tomorrow, we're stopping there. Okay? So tomorrow, if you'll listen, please, I will have a video for you that will be the back side of the notes. Now, I will tell you there's 3 rows of problems on the back side. I at most will do the top 2 rows. Okay? I don't usually do the bottom row currently. So I will be doing the example 3 row and example 4 row. Okay, that will be the plan for tomorrow. You'll see that in notes, and then you need to work on homework. From what last period told me, if you wanted to work a few minutes on homework now, there are a few problems at the beginning of homework that you can do. You know enough of the basics. So you are welcome to get started on that right now. I just figure it's a good place to stop and put all 3 of my classes at the same location. And the homework will be due on Monday. So you want to make sure you have it ready to go for Monday.